Petit disclaimer, cette session va être en anglais. So I try to switch in English to present the speaker. So please welcome Mey Beisaron. She's a huge Star Wars fan, as you can see. And she will talk to us about hints and tips to choose the right solution, especially in the here for Helm. So please welcome her with haute applause, please.
Thank you.
And May, may the force be with you. And the floor is yours.
Thank you. Hi, everyone. Thank you so much for joining. I would like to grab your attention for my R2D2 heels. The camera, you can give me the camera. I deserve it. Come on, they're painful. That's it. Ha, R2D2 heels. Give it up. Give it up. Thank you. Thank you so much, for the photo. All right, I am super excited and happy to be here. Thank you for joining me. That's my first DevFest conference, and let's begin. So today I am going to talk about how a unicorn migrated from an in-house solution to Helm. Let me give you a little bit of background about the company where I work at. So I work at Forder. Forder is an e-commerce fraud prevention company, and in simple words, we make sure that good consumers can complete their transactions while fraudsters are simply blocked. And why did I call this talk, why did I say unicorn? Well, first of all, it looks so super cool, so that's the first reason. And the second reason is that Forder is a unicorn company. So now you have both money and a unicorn in your eyes, and that's a great way to start my talk. So a little bit about what we do so you'll understand the context of things, of the environment that we need to keep up in the air. So our production environment needs to support 50 million decisions that are made every day in real time. And this is the compute environment that we have at Forder. Our main cloud provider, not the only one, but the main one that I'm going to focus on today is AWS. We used to work mainly with EC2 instances and VMs. And now, over the past 2 years, we have EKS, which is the AWS Kubernetes clusters. So Kubernetes migrations. Around 2 years ago, we decided to migrate to Kubernetes. And migration to Kubernetes, it includes a lot of stages and a lot of challenges. And here are the main reasons for why this is super challenging for us. We had around 600 applications and services that needed to be migrated. Each service or application had its own requirements, its own constraints. And we needed to do that with around 130 developers. So this is the amount of people I needed to talk to and convince to do those migrations. Because, even though we tell them that we want them to migrate to Kubernetes, they actually don't have to at all. And what I'm going to focus on today, the solution that we went with Helm. And when I say we went with, it's because we did have other options. And one of those options was to just stick with an in-house solution that we started with. So our in-house solution is an infrastructure as code, Python code, that actually generates CloudFormation templates, which means that this is how we generate the cloud resources with this Python code. And the way that we were able to decide what to go with was I just thought that it would be way smarter to go with an industry standard tool for something new like Kubernetes. Now, I say new today, it's not new anymore, but it was new back then. So this is why we went with Helm, and now this is what I'm going to talk about today. I'm going to talk about the Helm Chart's structure requirements, because even though we chose Helm, we still had a lot of choices to make. How are we going to create an architecture that our developers can work with? How can we create an architecture that we will have it, easy to maintain? And there are other requirements, and I'm going to show all of these to you. And about that, the requirements that I'm going to share with you today, I can tell you that I started doing those, going with these requirements for this specific project, but it later on led me even in other projects that have nothing to do with Helm. For example, another networking project that I did, these requirements were also there to help me when I started to think about the solution. So after I will talk about those requirements, I will talk about some different Helm charts architecture solution, and then I will focus on our solution. And by the end of this talk, I will talk about how we integrated this with the existing infrastructure as code. That Python repository I mentioned before, I'm going to show you that. But before I do all of this, let me talk a little bit about who am I. So my name is Mey Beisaron. I've been a backend developer for over 5 years. I've been writing in many different programming languages. I did a lot of batch processing, algorithms, and data structures. And then I did a lot of Kafka, all of the different databases. And I think that out of all of these things, the thing I enjoyed the most was to write in Clojure. Debate me about it if you know what Clojure is. Today, I'm a senior platform engineer at Forder for over the past 4 years, and I love that. I am also an international public speaker and a mentor, which means I help other people become the tech speakers that they want to be. So if you want to find yourself on this stage or other stages, just reach out to me. I promise I will help. And last thing is that I'm a party girl, but maybe not the kind of parties that you think. I like to join Diablo 4 parties, but then I mainly just loot things and I never help. Don't tell anyone. So yeah, now that you know all of these things about me and you already clapped for my R2D2 heels, I think we're ready to start. Okay, let's talk about our Helm Charts structure requirements. Okay, so here's the thing. When you work for a big company, you need to remember that you want to allow your developers to have their autonomy so they can do things on their own. But then you also want to have a good amount of standardization, because you're the one, as a platform engineer, you're the one responsible to make sure that people stay within the company's constraint. And so this is what I'm going to talk about, how can you balance between these two things. But remember how I said that the requirements I'm going to show you are actually pretty good, for leading you for other solutions. So this is one of those things. You want to always balance between developer autonomy and standardization. Obviously, if you work in a startup and you don't have many developers, maybe then you don't have to allow a lot of autonomy for the developers, because if you, a sole DevOps or 2 DevOps, are serving just a few other developers, then that's okay. But if we are a group of, let's say 6 or 8 DevOps today, we're serving 130 developers, then we can't do everything for everyone. We got to have developers' autonomy. So that's the first requirement. We want our solution to be self-serve. We want to enable developers' autonomy so they can change things on their own. We want them to be able to define their own resources. We want them to be able to define their own infrastructure. I don't want to be there for every single commit that they do when they want to create a new VM or a new pod or a new replica or whatever it is that they want. They approach me anyway, but at least I gotta try. Next requirement is to have things composable, which means that you want to have standardization by abstraction of infrastructure configurations. So there are things that I just don't want developers to touch. Okay, don't just leave it alone. And so it means that I want to have my infrastructure composed of small components, and then I want to have a good layer of abstraction. But on the other hand, I don't want things to be too abstracted away, because then it means that every time I want to add something new, I need to create this abstraction layer and maintain it. And this brings me to the next part, extensible. I want to make it easy for everyone, and the emphasis is on everyone, to add new abilities. Because let's say I developed some solution, and now somebody wants an HPA for their deployments, and we didn't implement it yet. So either they're going to wait for me, or they're going to do some weird hack. Both options are not so good. So my solution has to be extensible. So these three requirements are so crucial. This is what leads me, like I said, until today in the different solutions that I offer to my developers, not just in Helm. So these are the three things. So one last important thing, or you know what? It's the most important thing when you think of your next solution. Remember, as a DevOps engineer or platform engineer, you are measured by the developer experience. Because if you develop an amazing tool that nobody wants to use, is it really that amazing? So you need to make sure that people want to use the tools you develop. That's also true for other developers, but for backend developers, it might be a bit different, right? But yeah, when you develop a tool, and your users are right across the hall, if they hate that tool, you will know about that. So you gotta make sure that you have developer experience in your mind throughout the development process, from the moment you start to plan it to all the way to the execution. But think about this. You can't just show up to the developers when everything is ready and be like, hey, use that. Because then they'll be like, I don't know, who are you? What do you want from me? Okay? What you want to do is you want to have the developers in on it from the start. And I want to give you a small example of how I did it here. I'm going to show you the different options of the Helm Chart solution. But before I even chose Helm, I went to the developers with that Helm solution, and I showed them a POC of both the Helm solution and another in-house solution. And I presented those two solutions to the developers, and I asked them, what do you think is better? And they chose it themselves. And then later on, when I started to work on the different architectures, I kept on doing the same thing. I wanted that feedback loop from the developers. So remember, when I say developer experience, it's not just about making sure that your tool is nice and fun. Yeah, I guess CI pipelines can be fun, okay. So you don't want to just make sure that your tool is fun. You also want to make sure that those developers feel included, that they know that you care about the usage rate, okay, of the tools that you provide. So this is the tool I'm going to use for today in order to keep track of how the different solutions that I'm going to show you, where they stand between standardization and developer autonomy. Like I said, when you're in a fairly big company and you have a lot of developers to serve, you want to make sure that you're somewhere between these two. Okay, so let's see that. Let's go over these three things. I'm going to show you first a few Helm features. Even if everyone here is well familiar with Helm, I'm going to assume that you're not, and I'm just going to freshen up your memory. And then we're going to check out some common Helm solutions. I'm going to talk about when each solution is a good fit for what use case, and then I'm going to get to the base chart, which is our Helm solution. So let's say I have some front-end service, and this is how I would create its Helm chart. I would have the templates, which is where I will define like all of the different YAMLs and different functions that can help me prevent duplication of code. Then I will have the chart YAML and the values YAML, which is where I will define the values for my application. Let's talk about subchart, because subchart is the main thing that we used in our Helm solution. And there is another thing that is called library chart, and I'm going to refer to the difference between those now. So a subchart is actually a dependency that you mention inside your chart YAML. As you can see over here, I have the MySQL chart. And the idea of a subchart is that it can be deployed on its own, and it generates resources. And you need to remember this when we move forward. So remember, a subchart can be deployed on its own, and it is actually generating resources, Kubernetes resources. The chart that has the subchart as a dependency is called the parent chart. A parent chart can have multiple dependencies, and as you can see over here, I showed as if I have 2 dependencies. And another important thing is that the parent chart, so my service can actually override values in the subchart. So this is another important thing to remember when I show you the solutions that I'm going, the solutions that I had to choose between. The fact that I can override values mean that I can set up some different default values, and then the user can override these values with their own set of values. Now, sometimes people confuse a subchart with library chart, so let's make it clear. A library chart is not installable on its own. A library chart is there to prevent code duplication. It will only consist of reusable templates and helper functions. And like I said, it's mainly to avoid code duplication. It is not installable on its own. And we used it, but not as our main solution. So everything that I'm going to talk about today refers to a subchart. Okay, so now let's talk about some common Helm solutions. But before I do that, I have one important thing I would like to share with you. So a lot of times when people consider new solutions for their infrastructure, they start by checking out the newest tools out there. They need to decide between build versus buy, meaning are we going to build it in-house, or are we going to get something off the shelf? And one of the best ways to do that, and I can commit to that one of the best ways to make this decision is to talk to people from other companies. Now, it requires 2 things. Friends, first of all, and the ability to talk to your friends. And I think that these 2 abilities are not that much to ask. So if you talk to your friends from other companies who are either DevOps or platform engineers, and ask them, what do you have in your company? How did you do the migrations? I can tell you that all of the solutions that I'm going to show you today are taken from the biggest companies out there that you're all 100% familiar with. And I was able to ask all of those people is because I am going to meetups, I'm going to conferences, I talk to people, I make friends, and then I can call them and ask, how did you solve your deployment definition for Kubernetes? I highly, highly recommend that you do that as well, because it gives you a real perspective of different constraints and maybe different use cases that they had in their company. A lot of times, especially when it comes to DevOps, it's going to be kind of the same. So let's take a look at the different solutions now. The first one is just individual charts. It means that each repository, each service will have its own Helm chart, and it means that you can deploy each application separately in a single command. And this gives the developer complete autonomy. It means that the developers can write their own Helm charts. They can do that from scratch. They can import a third-party Helm chart. And this solution could work good for smaller startups, because a lot of times I saw that in those smaller startups, the DevOps is the one who's creating the Helm charts. And so it's okay because there aren't many developers, there aren't a lot of services, and then the DevOps usually know what they're doing, so they can define it on their own. Problem with that is that it creates cognitive overhead for the DevOps. It means that the DevOps it needs to be familiar with everything that is going on in the different parts of the company. And no standardization and compliance issues, those are things that will come up as your company will grow. So you have to consider that. A lot of times when we're a small startup, we go with one solution because it's easier for that moment, but you need to consider the growth of your company when you bring in new solutions. The next solution, the umbrella chart, I saw that in the bigger companies. But this is a solution that actually is perfect for when you want to be able to deploy your entire environment or your entire product with one command. If you need to ship all of your product in one command to your customer, this is a great solution for that because you can combine all of your applications into one big chart, but each of your applications will also have their own charts. Let's see what it looks like. So over here, you can see the directory. In the directory of the umbrella chart, which usually I saw that it's packed in its own repository. So in the umbrella chart repository, which is managed by the DevOps, by the way, and this could also still work for a very big company. I will not name those on stage, but like some of the biggest companies out there, they do it this way. So in this one repository, you have all of the charts for all of the applications, and then you can see that there is the main chart YAML and the main values YAML. These are the ones that will be active during deployment. So this is what it looks like if I do it on a graph. It means that the umbrella chart, like the bigger chart, has all other charts as dependencies. Okay, so let's say that the umbrella chart, let's call it chart A. So if chart A has other charts as dependencies, if you remember, a parent chart can override values of the subcharts. So it kind of gives some developer autonomy, but not a lot. I'll refer to this in a moment, but like I said, this structure allows you to deploy your entire application in one go, and it's great when you need to ship your product to your customers. And if you want to do multiple deployments in the customer's space, that's a great way to do that for everything together as in one command. So maybe I exaggerated with how high it is and how far it is from developer autonomy, but it really is like that, because if there is one repository that manages all of the charts and it's owned by the DevOps, be sure that the developers will be like, can you help me with this and this thing? Because now they are still coming to my repository, and they're like, oh, but it's your repository. Just tell me what to do. And then all of a sudden, I am still writing the charts for those 100-something developers. And it's not that good. But, I mean, I can still, if sometimes it's just, you can't avoid it. Like I said, those companies who need to ship their product in one go, this is how they do it. I saw it in more than one company. It's actually pretty good because also of the fact that you can override values of all of these subcharts. This, allows a lot of room for standardization. Okay, so another solution that I saw is multiple umbrella charts. So it's, instead of having like one big repository that manage everything, they just have a few repositories and they divided those by teams or by groups. So it means that each team or each product will have one chart that has all of its services inside, and now you can deploy different products with one go, but it's not everything combined together. It still allows the DevOps to have less cognitive load, because now I can, it's the responsibility of the teams. But for us, it was not good enough, because if I, the DevOps, decided to have some sort of default values that I always want everyone to use, now I need to go and change it and make sure that everyone has it in their umbrella charts. So it wasn't good enough for us, which is why we went with the solution that we ended up going with. Now, here's the thing. When we thought about our solution, like I said, I really wanted to make use of the subchart idea, where I can override values. I also like the idea of having one chart that combines a few charts inside. But actually, the idea for the solution that we went with came from Jenkins. And I know that's weird. But our solution for Jenkins, and I know that it's like that in a lot of companies, we have the main Jenkins file, and then in each repository, there is another Jenkins file that calls this main one, and then they can add more steps. And I wanted something like that, and that's exactly what I'm going to show you now with the base chart. So the base chart is a chart that serves as a dependency in each service chart. And we also have an individual chart for each service in their own repository. So what is that going to look like? It looks exactly like this. So we have the base chart. And the base chart, in there, we have we have all of the templates, and we have the YAMLs themselves. And check it out that we also have a values YAML and a chart YAML. And remember how I said that a subchart can also be deployed on its own, and that's exactly what we have here. If you deploy this base chart on its own, then it will create just a general new service. So the developers can, all they need to do, if they want, is just add 2 files in the repository. One file will be the chart YAML, which defines the name of their application, and also it defines the dependency of the base chart, and then the values YAML. In the values YAML, you will see in a bit that what they need to do is to override values, but they can also not override anything at all if they don't want to. Let's see the structure over here. So this is the structure of the base chart. As you can see, we have templates for defining different resources in our Kubernetes offering. And we don't only have YAMLs, we also have some templates inside, which helped us to avoid code duplication inside of that base chart. And here's an example of a chart YAML of a specific service. All they have to do is mention the base chart as a dependency. And then if we look at an example of the values YAML, my service chart can override values of the dependencies chart. So they can, all they need to do is to mention that under the base chart, and then they can change the replicas, they can change the metrics, and et cetera, et cetera. But like I said, even if they don't override anything at all, they are good to go with a default set of values. And then a lot of times we saw that people were able to use that as a jump start. Okay, they saw what happens when they deploy their application, and then they were able to optimize all of the different values that they had in there, the resources, stuff like that. And it actually worked. So like I said, what does the base chart has? It has its own values, it has the YAMLs, and then each service chart has the base chart as a dependency. And first of all, I want to mention how we called that base chart, because I didn't say it yet. We called it Chartmander. You know, not a lot of laughs, but okay. It's not that funny, I know, I'm just kidding. It's not funny. Anyway, I get overly excited by namings. I can spend hours on finding the coolest name. My manager hates when I do that. So base chart. This solution was the perfect balance between developer autonomy and standardization. because we allow the developers to create their own charts, but then when they have the subchart as a dependency, we can make sure that we give them good defaults. I will show you in a bit how we integrated that to our existing infrastructure's code. But what I have to say is that the developers are able to add, first of all, more charts if they need, because we said they can have multiple dependencies. So if they wanted to have like a third-party chart added as a dependency, they can do that. Of course, they need to go through security first, but they can still do that. And then also, when they wanted to add some things, they were able to do so. And this is where these three, I bring them back, because I wanted to remind everyone of where we started. This solution is self-serve. Like I said, they can each write their own Helm chart, or they can just write the values YAML and go with that. It is composable, which means it is constructed of simple, smaller parts with an abstraction. This layer of abstraction allows the developers that don't want to mess with anything, not mess with it, and those who want to add more things, they can. So this example of the HPA that I told you, it really did happen. Somebody did, one day, they're all of a sudden asking for HPA when last week they didn't even know what Kubernetes is. So I was like, okay, yeah, go ahead and add it. So now they can Google that, or today ask chat about it and add it to their chart, and they don't need to wait for me until I add it to the base chart. Now let's see the CI/CD flow of our Helm charts. Okay. So this is the CI. That's how this is, it's a simplified version of what happens when a user creates their Helm chart. We use GitHub webhook to trigger the Jenkins pipeline. And with the inside the Jenkins pipelines, it will ship the Docker image to AWS ECR, and then it will push the Helm chart to Artifactory. The reason for that is because Artifactory is pretty expensive, but it's really fast. So we only use that for charts. And for images, we use the ECR. So it means that once the application is actually deployed to Kubernetes, the image will be pulled from ECR. This is what happens with CD. We use Argo for our continuous deployment, and Argo will pull the Helm chart, like I said, from the JFrog Artifactory. By the way, I can tell we work with Artifactory for several different things, and I can tell you that their Helm support is actually pretty good. And I'm getting nothing for saying that, so. So that's it. So yeah, Argo is doing the Helm install to our Kubernetes cluster. Now, like I said, we were not starting from a greenfield. We did have to integrate with our existing infrastructure as code, and I mentioned that by heart beforehand. But let me just give you a better look at what I mean when I say Python infrastructure as code. So this. I did not name this repository, by the way. This repository is named Rugatka. Yeah, not my name. Should have been a Pokemon something. Anyway, so this Rugatka repository, the Python code that generates the CloudFormation templates. Over there, you as a developer or as a platform engineer, you write Python code, and you can define your queues, your blob storage, whichever one you chose, different databases, and obviously the roles, the AWS roles that you need for your application. And then what will happen is that we have a Jenkins pipeline in there, but we had enough of Jenkins. So let's just imagine that it ships magically to CloudFormation with the API, and it actually generates the resources. All of these resources are managed by CloudFormation. So what do we do if, let's say, I created a queue, and I need the URL of this queue I need this value in my pod, inside my application. Other things that I might need are URLs of the blob storage. I might need the ARN for creating the service accounts, and so on and so forth. How do I do that? How do I get those values that are being managed and generated in that repository, and then it's managed by CloudFormation? So sometimes, when things are ugly, the only solution is to make things uglier. And that's what we did, and that's what I'm going to show you now. So we wanted to get those values somehow to be shipped to our applications. And this same Python code that generates CloudFormation templates is now also generating even more things. It generates a values YAML. And not only values YAML, it will also generate the service account and also application set, which is what you need in order to have your application up and running and deployed via Argo CD. And it was a choice. Like, we had to think about it, because on one hand, we didn't want developers to have to define their applications, both in this repository, the Rugatka one, and then also in their own repository to define the Helm chart. But extracting all of that out of this Python repository was definitely out of scope for this project, and we had to decide between, development time and just getting to production. So we realized that there is no other way around it at this point, and this is why we went with this solution. And sometimes that's the only way. But then what it meant was that we needed to communicate this to our developers and also explain to them the reason for why we did that. Because now I'm going to ask them even more things. I'm going to ask them to define their Helm charts, and I'm also going to ask them to define some things in their in the Rugatka repository. So it went okay, I guess, and I know that some developers had a little bit of hard time, but we just listened to them, and what we did is we adapted the Python code to be easier. So now everything is abstracted away, and they keep on just writing simple Python code. Honestly, simple Python code, and it generates all of these resources that are written up there: the cloud resources, the application set, the service account, and the values YAML. Let's see an example of what it looks like, what is being generated. So over here, you can see that this is the values YAML, or the YAML that will be generated by this Python code. So it will have the service account, and it will have the different values that the developer needs, and this is happening automatically. So let's say that you defined an SQS in your application, or you defined an S3, then you don't, and if you just inherit the Kubernetes library, this will be generated automatically. So at the end of the day, they didn't actually have to do a whole lot more in that Python repository, not a whole lot more than what they were already used to doing, because they were already used to defining their SQS in that Python repository. So this is being generated, and then let's see what it looks like on the other side, like on the Helm chart side of things. So the Helm base chart consumption, this is what it looks like. We're just referring to the values, with a little bit of ifs to make sure that those values exist. They're mandatory values sometimes, and sometimes it's optional. Further down the road, we allowed the developers to add even more values, because some of them thought of things that we didn't think about. So we added another section in this values YAML. We added another section for just free values that they want to pass on to their function, to their applications. And then what it looks like during deployment, it looks like this. You have the Rugatka repository that creates the cloud resources, and then it ships also those YAMLs to the JFrog Artifactory, and then Argo CD watch and pulls the changes from the JFrog Artifactory. And during deployment, Argo CD, if you do apply, and you mention a few values YAML, the last values YAML values are the ones that will count. So you can always override the values of all the previous values you have. I hope it makes sense. I said a lot of values, but I hope it makes sense. I'm almost done, and then we'll have time for questions. What happens today? Do we still have that one base chart? Haha, one chart to rule them all. Okay, a little laugh. A little better than earlier. Okay, I'll live with that. So no, we don't have one chart because it's too much. We have so many things to define. So we just took it apart, and now we have a base chart for different things. So we have a base chart for HBA. We have a base chart for ingress, and we have a base chart for secret management, and we have a base chart for deployment, and for metrics, and so on and so on. So we have several different base charts. They can all be added as dependencies to the charts of the users. So it means that some users decided not to use one of our base charts, and they wanted to write their own secret management, their own config maps. So they just didn't add it as a dependency, which made a lot of sense. And this is true composable infrastructure solution. And yeah, I think with that, I will remind everyone where we started. We talked about the requirements. Remember, when you define a solution, try to think what are the things that are crucial and what are the things that are okay to have. It's not always worth it to go get an off-the-shelf product. Sometimes it's good enough to have your internal solution. Sometimes that's the only way. If things get ugly, just make them uglier. There is no other way, because there is also the time of development that you need to invest in things, and this matters. Because if I gave them the solutions 2 years later, maybe it wouldn't be so good. I mean, we needed Kubernetes up and running already. Remember to balance between developer autonomy and standardization. This is highly affected by the size of your company. If you have a lot of developers that you need to serve, you can't allow everyone to do whatever they want because you have compliance and you need to have stricter rules. Don't forget about developer experience, and definitely don't forget about your developers. You want to make sure that you build the trust with your developers. There are many different ways to do that. One of those, for example, we did an internal Kubernetes workshop. You can't assume that they know everything. You can't assume that they want to know everything about Kubernetes. It is not part of their main job definition. Okay, their job definition is to develop their applications. And you go there all smug, you don't know Kubernetes? I mean, don't do that. If you want them to know something, help them. And just by sending a bunch of documentation, you know they're not going to read that. And they're right. Nobody wants to read documentation. It's long, it's boring. So it's either that they're going to ask you a lot of questions, or you give them a good developer experience that they don't need to ask you anything at all. And with that, I will say thank you.